When AI and automation headlines hit the news, the first thing everyone worries about is job displacement. Will robots take my job? Will my kid need to learn to code? The common narrative seems to focus on a machine replacing a human. But that's just the headline. You see, the real challenge isn't replacement, it's augmentation. It's Human+Machine. And the fact is, this real inflection point happens when machines find a way to successfully work alongside humans. It's not a job crisis. It's just an upskilling emergency. It's about us rethinking what the leaders of tomorrow and the careers of tomorrow will look like and getting ourselves ready for that new revolution. Today, we're going to dive into this discussion. These massive mandatory changes required in education and workforce development. We're asking ourselves, how do we best prepare our kids and our colleagues for a world where AI is the co-pilot? AI is the agent. AI is managing the process. But human skills like critical thinking and empathy continue to be at a premium. It's my absolute pleasure today to explore this critical evolution with John Colgrove, our founder here at Pure Storage and our Chief Visionary Officer at Pure Storage. Cos, welcome to the show.
Thanks for inviting me.
So maybe just introduce yourself to this audience. You've kind of lived through several of these revolutions, evolutions. I don't know. I mean, try to compartmentalize all the experience you've had and everything you've thought about some of these dramatic changes that have happened. And give us your perspective. Where's the world gone in the last 40 years, and how have we kind of continued to embrace and evolve for technology?
Well, I think I tend to actually think even longer term than that. Over the last 200 years, 100 years, pick your time frame, there's a lot of things that have revolutionized society. And, a lot of people are like, oh, this is going to destroy everything. I'm afraid of this. I'm afraid of that. And it hasn't happened. Let's take maybe the most recent one, when people started actually saying, oh, we're going to have personal computers and widespread computer use. Everybody was afraid that's going to take away all sorts of jobs. And instead, you look at what happened. There's a set of jobs like you're a plumber, you're a carpenter, not really affected, but you're an office worker. Now you have a new tool, a computer, and you have, gradually you got new programs, right? So you went from just having a computer that replaced sort of your typewriter and maybe did a little document editing. And then you got like a spreadsheet, and it started replacing some of those tools. And the people that were successful learned how to use the new tools and found themselves augmented, as you pointed out. And there were people that refused to embrace those tools, that refused to learn, and they're the ones that went by the wayside. I think it's the same thing this time around. I also know, I have two kids that my oldest son is just about to graduate from college, and he keeps telling me it's like AI is destroying all the entry-level jobs. And I sort of point out to him, so if AI took all the entry-level jobs, then there'd be no entry-level jobs, so nobody gets into the job market. So then as people get promoted up, nobody replaces them, and it's like it doesn't make any sense.
So you and I have to work forever.
You still need the entry-level jobs. You might have, fewer of them in some fields, more of them in others. They might look different, but it's a set of tools and a set of skills. And as has always been the case throughout human history, the people that embrace the change, the people that learn, will have an advantage. And the people that decide they're afraid of it and refuse to learn will be at a disadvantage.
So take us on a journey. So you and I have talked about your early days back in college, where you were organizing time cards to go into the original mainframe computers of the day. And what was that augmenting? What was that new process doing in a way that hadn't been done before? And you embracing a lot of that early on actually helped you get an edge. Can you kind of take us into the time capsule and help us understand that?
Well, I started out, I did program on punch cards a bit. My first job in the industry was actually tearing paper off a line printer and putting it into bins for people to pick up their printouts.
Wow.
And the thing that you had back then, much more, computing started out at much more centralized, much more sort of big tools and less accessible. And it's just continued to get more and more accessible. And I don't think there was some magic moment. People, businesses recognized that, oh, here's a tool. I can use it to do something more efficient. It didn't mean that they got rid of folks. It meant that they said, okay, I've made their job more efficient. And you see that, with AI. I was talking to somebody the other day, and he's like, okay, I had to give some performance feedback on someone. And I went and I wrote like, 3 sentences. And then I asked an AI tool to go find supporting information for it. And it went and did all the research to go back and pull from emails and documents and things, the material to support that. It's just a more efficient way of doing it. Kind of like instead of looking through a filing cabinet for something, you have a little search bar on your computer and you type in something to search for it and it finds it, right? It's just more efficient.
So am I hearing then when you think about AI, it's less about the artificial intelligence, it's more about augmented intelligence?
Absolutely. I have not yet seen out of AI what I would call the creativity and imagination that people have. Uh, AI is great for doing a repetitive task. It can take something that, someone in HR or someone in finance had to go and do 100 times, 500 times, and do that for them, right? And again, it doesn't replace what they do. It just augments what they do. No different than the way AI's augmented coding, as an example. When I was first starting out, you'd write a computer program and then you'd have like, oh, here's a subroutine that does this and here's a subroutine that does that. But you still sort of had to do every step of the logic. And as languages moved to higher and higher level languages, the language started helping people do more and more of the basic things. And if you think about it, when you program, the syntax is very important. If you don't tell the computer exactly the right thing with exactly the right punctuation, it's just like, I don't know.
Sounds like a prompt. Yeah.
Okay, now I can prompt in a more natural language, and the AI takes care of getting all the syntax exactly right. And, I don't sit there and, I tell the AI like, oh, well, okay, I need to do this and I need to add this and multiply it by that. I'm never at risk of, oh, I forgot the parentheses. And so it did the multiplication at the wrong order, or things like that. The AI is just, enabling people to do better by taking the less creative parts of what they do and doing that for them.
Okay, so let's dive in. So obviously you've written a lot of code, you built a few companies, you know a little bit about engineering. I'm saying that kind of tongue in cheek. When you think about where we have gone with this code, going from traditional coding to efficient coding to low code to no code to prompts, what's your take on this human+machine shift? When we think of the companies of tomorrow and students who are studying engineering today and will build the solutions that are sold by these companies of tomorrow, ultimately, how do you define the plus? Where are machines and humans going to find this, essentially this harmony, this balance that's really going to push our innovation and the next generation of products to the forefront?
Well, so let's start with maybe the first thing that comes to mind, which is when I have an idea, I can create a prototype 100 times faster. If I can describe what I want to, the right AI tool, my prototype's done. And, that creates just a huge augmentation of creativity, right? So now every time I have a creative idea, it's like, there's no obstacle. There's no, when can I find like a few weeks to work on it? How can I slave away this weekend to work on it? I can get it done much, much faster. I think the other parts of it, when I'm actually going to now build a product, again, if I start by having a crisper description, and in some ways, this is going back more to the way things might have been done 30, 40, 50 years ago. Many years ago, you would write a detailed design spec, and then you'd have a team of programmers that might take that design spec and actually turn it into code. And then we kind of evolved as we evolved to higher level languages, more tools, sort of more the languages help and developments, toolkits, help you do more stuff. We evolved a little bit away from the idea of a spec. But now we're back into a world where if I can produce a good spec, I can have the AI turn that spec into the code. I can have the AI turn that spec into the test cases to validate it. I can have other AIs look at it and tell me where there's flaws in my logic. And so people still need to think in logical steps. People still need to be able to break down a task into a set of specifications, a set of things to be done. It's just you now have tools that then take, once you've done that mental work of breaking it down, sort of the implementation goes away from you.
Okay, so if I think of traditional engineers who grew up in the world of COBOL and C++, and I think of new engineers, new software engineers coming out, building, on Ruby or on Rails or whatever it happens to be, how should they kind of look at this as an opportunity? How should they really say, okay, in the world of software engineering, in the world of building the next company, how do I get an edge here? What would be your advice to them?
You got to learn how to be very good at creating specifications. I mean, I think that's the biggest edge. If I can create a proper specification, I can have the tool do all the grunt work.
And is that building specifications, is that something that software engineers typically don't spend a lot of time on, or is it something that is less important today to punch in code?
I think it's something that people have spent less and less time, over recent years. So again, you go back to like the 60s and the 70s, you'd, take your code, when you had like batch programming models and things, you'd take your code, you'd write it, you'd be very careful in what you wrote, because then you'd submit it to the machine and you might not get an answer back for a day. So the last thing you ever wanted to do was submit it with some really simple error that would just waste a day. And, I remember when I was in school, the people that worked on those batch programs, what they would actually do is a very standard working method. They'd sort of get their program all set up. They'd submit the job. They'd go to the vending machine, get a snack, chat with their friends for a few minutes, and then they'd take their printout of what they submitted and their last results, and they'd start going over it, and they'd usually find a few bugs before the machine even came back with their next set of errors. You'd think, why on earth didn't they do that in the first place to find the bugs first? But, people worked like that because it was expensive in their time to have the computer run something. And as it got cheaper and cheaper, time sharing came along, and I got my personal computer, and it's a lot faster than it used to be. And
your iPhone's faster than the mainframe now.
My iPhone's faster than the old mainframes. And so you got to more instant gratification. Oh, hey, I've typed this up. Let me just see if it compiles. Let me see if it runs. And I think that got people a little bit away from being quite as careful with what they did and quite as careful in specifying it, because it became a little bit more like, I'll try it out and then I'll fix it, and I'll try it out some more and I'll fix it.
And the throwaway cost is nothing, essentially.
Right. But here you now have something that if you get the spec right, everything's right.
Yeah.
But before, you'd get the spec right and you'd still have a whole bunch of human errors translating it into the actual code and things. Excuse me, and the actual product that you're building. And now if I get the spec right, everything's done for me. So I think you're going to see those more of the COBOL programmer types will have a little bit of a renaissance.
Yeah, so I want to dive into that because Everything you just told me says software is getting easier and easier to build, and more people have access to being able to build it, and essentially being able to build programs. But, building a leading product, of which you've done in several companies, you keep talking about these specifications. You keep talking about this human understanding the use case, understanding what problem they're trying to solve. Do you think AI helps there, or do you think it's still going to be largely human to map the problem to the solution, even though the computer's writing the code?
I think AI can help a little bit, but I think it's still largely human. And there's also another element that to really get the maximum efficiency, you're still going to have some understanding of how does a computer really work. And if you think about it, one of the other things that has naturally happened as the computers have gotten faster, as they've gotten more available and more accessible, the number of people that do programming without actually really understanding how a computer actually works is grown tremendously. And those people will have no problems doing products and programs and code and all sorts of things that are not trying to, let's call it, get the absolute maximum efficiency out of the machine. The people that are doing the sort of cutting edge, I've got to get every ounce of efficiency out of this, they're still going to need to understand a lot more how a computer really works.
So if I get just a little bit geeky for a moment, if you think of the old world of assembler, where I actually physically was deciding which register I would address and what particular piece of data I was moving and how I was moving it, you're saying that knowledge is still really important. Although today, somebody writing an app for the iPhone, do they really understand how the iPhone works?
Yeah, well, but I would argue for the vast majority of those apps, it's not so critical. For the sort of the operating system that runs the iPhone, it probably still is, but for most of the apps, it's not that critical. It's the same thing if you look at the people building the gigantic data centers. If I understand exactly how, where the bottlenecks are in the memory subsystem and can do some things to make that more efficient, like zero copy on my network traffic and stuff, I can make a big difference. At large scale, at ultra efficiency, that still makes a big difference. Small scale doesn't matter at all.
No, I love where you're going with this, because I'll just take one little segment of the market. Let's think of electric cars just for a moment. So one solution to range is a bigger battery, but that has all sorts of engineering challenges with it. The other solution is, how do I actually get the car to use less power while delivering the same experience to the user? And I think what you're telling me is the real magic here is figuring out how to consume less power, not necessarily just building a bigger and bigger battery.
Yeah, no, I think that's certainly true. Now, with the cars, I'd point out that aerodynamics and weight are probably the biggest things that go into that. So in that sense, that's maybe a little simpler one, but okay. Can you have your AI help design a more aerodynamic shape? I remember going to a presentation at the Monterey Bay Aquarium. They were pointing out that the boxfish, which does not look very aerodynamic, turns out to have an extremely aerodynamic shape moving through the water.
Huh.
And, so somebody was positing that, okay, we're going to start building cars more in the shape of a boxfish. And you've seen a couple of cars out there that are more like that, and they're very aerodynamic. So there's the things that you can definitely learn from somewhere else. Like, I do not know if you just took an AI program and said, let's design the most aerodynamic car possible, whether they would pick the boxfish, whether they design something better still, or whether they design something that's good but not imaginative and great. I remember another aspect from that presentation. The windmills They figured out that the windmills actually generate more energy in lighter winds if you give the blades the same kind of shape as the fins of a humpback whale.
Hmm.
Millions of years of evolution have apparently found some good solutions.
Really, nature might be better than AI. Yeah.
And well, so I don't know what the AI would pick if you said, "Oh, design me a really efficient blade for a windmill." And at this point, I guess I'll never know what it would pick, because I'm sure by now it's seen the same presentations and heard the same lectures and seen the same data. But I haven't yet seen that kind of what I would call leapfrogging creativity.
The novel thinking, the novel idea, the real revolution instead of innovation. Kind of, what is this revolutionary concept? I'm not sure we won't get there, but I would completely agree with you. We're not there today. Wow. So much to unpack here. An incredible context. Folks, that wraps up part 1 of our discussion with Cause on the philosophy of augmented intelligence. But how do we actually build the products and careers of the future? Well, I'm excited to invite you all to join us next week for part 2, where Cause will get into the grit of how AI is likely to evolve roles in engineering and impact organizational strategy around the world. As always, please send us your comments, and please like and subscribe to the IT Headline series so you don't miss an episode. And if you're looking for more data, tech, and IT news, check out our new site, thedatawire.com. With that, and for John Colgrove, our own Cause, we'll see you next time.